Hello, this is John from TC Math Academy. And what we're going to be doing in this video is checking your understanding of functions. So you can see the title here says, hey, do you understand functions? And of course, we're talking about functions in mathematics, functions in algebra. Well, if you have a solid understanding of functions, then you can answer these three questions. I'm going to show you the questions here in just 1 second. But certainly this little pop quiz is not going to be all inclusive about functions, and it's going to be designed for students who are like first year algebra students. So if you're in a course like Algebra 2, College Algebra, Pre-Calculus, things like that, then you should be able to ace this pop quiz. But if you're taking a course, let's say like Pre-Algebra, don't shy away from this quiz as you very well could pass this as well. But even if you don't pass it, you're certainly going to learn something. So I'm going to show you these three questions here in just 1 second. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if you like this video, if you enjoy it, if you get some benefit from it, make sure to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and get into this right now. And by the way, I would say that try to refrain from kind of, looking at the questions and then getting your notes or looking online, trying to figure out the answer. Just kind of see what you know. And let's see what you know about functions. This is going to be a 3-question pop quiz. And let's go ahead and start with question number 1. And one thing about this particular pop quiz, it's not going to be in any particular kind of order of like basic stuff all the way into more advanced stuff. It's just going to be an interesting little, pop quiz again, just to see what you know about functions. So the first question is the following: find the inverse of this function. Okay, so here we have a function, and I'd like you to find the inverse of this function. Okay, so obviously this is the first time you're seeing this question, so go ahead and pause and think about it. Feel free to use as much time, by the way, to answer these questions. This is not a timed pop quiz, and hopefully, you kind of know what to do. So I'm going to give you just a few seconds to pause the video before I start answering this question. Okay, so do you have your answer? All right, now if you need more time, again, pause the video and work on this. But here we have a set of ordered pairs, coordinates, right? So I can kind of get really deep into this. First question is hey, is this even a function? Why is this a function? So if you're looking at this going, I don't even know why this is a function. Well, you need to do some work on this. Now, if you are taking like an algebra course, just check out like my Algebra 1 full course instruction. That's going to really help you out. Also, I have a ton of additional videos on my YouTube channel on all this stuff, but functions is a critical part of mathematics. But in fact, this is a function because every x here, let's kind of just quickly review this. I'm going to be skipping over a lot of kind of foundational instruction here, okay? But I'll try to quickly highlight the most important concepts, but I'm sure I'm going to be skipping a lot of stuff because this is a huge topic. But what we want to notice here is that we have 3 ordered pairs, 3 coordinates, right? X, Y, points, okay? Now, these points, of course, we could plot on the X, Y axis. But in essence, if you notice, what you want to really be paying attention to, and we're first just establishing that this in fact is a function, is that every x value, let's kind of highlight these x values. 1 is the x value here of this coordinate, 2 is the x value of this coordinate, and 7 is the x value of this particular coordinate. Every x value is paired with one unique y value. Okay, so this is kind of by definition one way to describe, excuse me, what a function is. Now, let's kind of just look at it differently here. Okay, so when we're talking about functions, we have something called the domain and range. We'll just kind of construct a quick, what we call a mapping diagram. So here's the point 1, 3. So 1, okay, the domain is always your input values or your x variable, and the range is the output values or the y variable. Now the domain, the x values, is also the input, or excuse me, the independent variable, okay? And y is the dependent variable. So your output is dependent upon your input, okay? So here, 1 is mapping to 3, okay? So we're constructing a mapping diagram here, and 2 is our next x value, our next input, our independent value. It's mapping to 5, and 7 is mapping to 9. Okay, so in this little kind of mapping diagram, we can kind of clearly see that for every x value, it's pointing to only only one y value. So for example, let's say I have 1, it's mapping to 3. What if 1 was also mapping to 5? Now, if that was the case in our little set of points here, we would have this point 1, 5. So I could, kind of write this question out, make it a little bit more advanced. I could tell you, is this a function? And if it is, tell me the inverse function, right? So I'm kind of answering, or kind of explaining why, in fact, this is a function, because it's just going to make the solution to understanding this question a little bit easier. Okay, so hopefully you get this now. Again, if you are kind of lost, then use this as feedback to go back and review functions. Extremely important topic in mathematics. Okay, so in fact, this is a function because every x is pointing to one y. We can kind of see it easily with this mapping diagram. Now, the question is, find the inverse function. Well, you can't find the inverse of something that's not a function. This is a function. We kind of already established that. So what is the inverse function? Well, it's super easy, okay? What the inverse function is that the domain here's the function, right? We'll call this the function, and our inverse function, we'll use this notation. Now, the domain of the inverse function is going to be the range. So the range now becomes the domain of the inverse function, and the domain of the function becomes the range of the inverse function. So basically, these positions just get swapped. Okay, so let's just go ahead and draw a little mapping diagram like so. So 3 maps to 1. 5 maps to 2, and 9, I can kind of squeeze down here for a second, will map to 7. All right, so to be a little bit more direct about this, let me just go and erase this. The inverse of this function is simply the set of these coordinates where the x and y is switched. So that would be 3, 1, comma, here we just go 5, 2, and then comma, 9, 7. Okay, so this is the correct answer. And now if you got this right, that's fantastic. And if you understand everything I'm talking about, that's even more fantastic. And I didn't tell you in advance here that these were going to be super easy questions, like, given this function right here, x plus 3, find f of 2. Okay, now this is a real basic question. Hopefully you can answer that. But when I make a test, okay, when I make a pop quiz, I really like to challenge students. So, if you're looking for something super easy where it's not going to really challenge your understanding, then you might want to go someplace else. But if you're looking to put your brain to work where you can kind of get these expressions, you're like, I have to think about this for a second. Maybe I don't know functions as well as I do. Then, stick around, right? Good questions force you to think, and that's what I try to do when it comes to mathematics, because if you can figure this stuff out, then that shows that you have a pretty deep understanding of the topic. All right, so that's question number 1. You can give yourself credit for that if you think you got this right. But let's move on to question number 2. All right, so the second question here is find the range of this function. So I have the function f of x is equal to x squared plus 2, and I have the graph of this function right here. Okay, so go ahead and find the range, or describe the range of this function. Now, again, here I could have made this more complex. I could have just given you the graph just like so. Okay, and I could have said, is this a function? And if it is, tell me, what the range is. Now here I'm describing the function. I'm giving you an equation for it. F of x is equal to x squared plus 2. So this is a quadratic equation a parabola where we have a y-intercept at 2, okay, just as the graph indicates. Now, what is the range? Well, the range, kind of going back over here, is the set of all output values in the function. Now, it's a little bit hard to see this way because here we're only dealing with 3 points on the xy plane. Here we're dealing with a full kind of continuous graph, right? But basically what you want to be thinking about is where does this graph go in terms of the y-axis, okay? So let's just take a look at the domain here, because once you understand the domain of this function graphically, then it's going to be easy to understand the range. So when we look at the domain, now we are talking about this set of real numbers here. So if you look, the x-axis again is associated with the domain of a function. All right, it's our input values. Input is also our independent variable. Okay, so in other words, for this x value right here, whatever it is, let's say that was 3, we have a respective y value that's up here, okay? So in other words, we have this xy point that's on this graph right here. We're going to start with the input value of x, and to get the y, we're going to plug it into our function, right? So we would go here, f of 3, that's equal to what? That's going to be 3 squared plus 2, or 3 times 3, of course, is 9 plus 2. And if I did this right, that would be 11. So this coordinate right here would be 311. Okay. Now again, our input value, which is a part of the set of the domain, right, is 3. We plug it into our function, and we get an output value, which is a part of the range. Which in this case, it's 11. Okay. Now, the y value is going to be part of the range here. Okay, that's what we're looking for, and it is the dependent value. It's dependent upon what x value. So when you look at the x-axis, you kind of have to kind of visualize this here, kind of use your spatial awareness. You're looking at all these x values. You're like, okay, for every x value here, there's an associated y value right there. This x value, if I plug it into a function, I'm going to get this coordinate. If I plug in 0 right here, I'm going to get what? 0 squared is 0 plus 2. I'll get this point there. So the domain, you're kind of looking at, where does this graph span along the x-axis? Well, if you look at it, you can see that this graph spans the entire x-axis, meaning that the domain of this function is the entire x-axis, right? Well, it's basically all values along the x-axis is the domain of this particular function. So we would just describe that as a set of all real numbers. There's basically no restrictions. However, when we kind of look at this in terms of the y-axis, let's kind of erase this now, erase all of this stuff right here. Well, when you look at this in terms of the y-axis, this is what's going to kind of give us or describe the range of the function. Okay, so now you can see the entire x-axis is covered. This graph spans the entire x-axis, but this graph does not span the entire y-axis. So when you're looking graphically to determine what the range of a function is, you want to see, where does this graph span along the y-axis? Well, that's a different story, right? It's only spanning this part right here. It's only kind of covering this, right? So when we look at this in terms of the y-axis, or the output values or the dependent values, well, the only y values that are being associated here is all y values that are greater than or equal to 2. Okay, so it includes 2 because the graph goes through 2. So this would be the range. Okay, so to be a little bit more formal about it, you could say all y's are greater than or equal to 2 such that y is an element of the real number system. That's one way you could describe the range. You could also use interval notation, which is a little bit fancier. So that would be a close a bracket at 2 parentheses positive infinity, like so. Now, if you're not used to this notation, this is called interval notation. It's just a little bit more advanced. This is stuff that you would learn maybe like in college algebra, possibly in good college algebra courses, algebra 2 courses, certainly in pre-calculus, but you can also describe the range of the function like this. Either way, if you got this correct, that is fantastic. Okay, so let's go ahead and get to our last question. And here, I want you to go ahead and find the domain of this function under the set of real numbers. So we have g of x is equal to 1 over the square root of x plus 2. So go ahead and take a moment, pause the video, and go ahead and describe the domain. And hopefully, if you were not quite sure about the domain and range, you have a better understanding, because just for us, by us reviewing some concepts in the last previous questions. So hopefully you can figure this out. But let's go ahead and get to the answer. If you need more time, go ahead and pause the video. So basically what we want to be thinking about, again, we're going to be talking about the domain under the set of real numbers. And it's important when we're talking about domain and range, you have to discuss under what number system. Okay, so we're going to restrict ourselves to the real number system. Okay, and basically there's two conditions that we have to, stay away from in terms of functions. Two scenarios that we cannot have. The first is when we're talking about a fraction, we have a numerator and denominator. We can never have the denominator be equal to 0. We can't have a fraction where we have a 0 in a denominator. That will blow up the function. Okay, so that's a condition that can never be a part of the domain. Okay, so any number that causes that situation, you cannot have. Let's take a look at a basic example. If I have f of x is equal to 1 over x, what's one value that will clearly blow this function up? Well, if you went, well, let's find f of 0, you would have 1 over 0, and that is a big no-no. So 0 is the only value that would cause this scenario. So you got to take 0 out of the domain. So you can have all of the real numbers except for 0. So that's the first condition you have to stay away from. And the second condition, when we're talking about the set of real numbers, is you cannot take the square root of a negative value. Now, of course, you can take the square root of negative 16. We're talking about imaginary numbers. But again, imaginary numbers is part of the complex number system, not the real number system. So again, when we're talking about finding the domain under the real number systems, you got to stay away from negative values underneath square roots. Okay, so these are our two conditions. So when we look at this, I'm saying, okay, I have kind of two things going on here. I have a fraction. So the first thing is x plus 2. When I just look at this right here, this x plus 2, it cannot be equal to 0, because if it was, I'd be trying to find the square root of 0, which is, of course, 0, and I would have a 0 in the denominator. So the first restriction I have is that x plus 2, you cannot be equal to 0. Now, we'll kind of figure out, kind of clean this up in a second, but we have to look at this function in terms of restrictions. Now, another thing that we got going on is that x plus 2 is an expression, some value, right? It cannot be negative, okay? So if it cannot be negative, then therefore it has to be positive, right? So it could be 0. In other words, if this expression was in the numerator, you can take the square root of 0. Of course, that's 0. But here, we already said it cannot be 0, so x plus 2 must be positive. Well, if x plus 2 is a restriction, if x plus 2 as that expression has to be greater than 0 and it cannot be 0, then all we have to do is determine where x plus 2 is greater than 0. So let's go ahead and figure that out right now. Super easy. So we're looking at this. All right, this has to be positive. It cannot be 0. So x plus 2, you have to be greater than 0. So to solve that inequality, we simply just subtract 2 from both sides of the inequality, and we got all x is greater than negative 2. Okay, so that is effectively the domain, but we want to kind of write this in a nicer way. So I would say the domain is all x is greater than negative 2, such that x is an element of the real number system. So that is one kind of proper way to write that. Also, you can use interval notation and say, okay, the domain, you can be negative 2, not equal to negative 2. So that's open parentheses all the way to positive infinity. All right, so just a real quick recap on interval notation. What we're talking about is the following. Here's 0. Here's a negative 2. So if I was to graph it, it's an open circle, negative 2 going towards positive infinity, right? It's increasing. So this is all x is greater than -2. That's perfectly fine. All these values can be part of the domain, but in interval notation, if it's not equal to, it's an open parenthesis and -2, and then a comma, positive infinity. So if you're not familiar with this, I'm going to suggest that if you're at this level, check out my pre-calculus course. If you need something a little bit more basic, check out my Algebra 2, College Algebra, or Algebra 1 course. But whatever you do, make sure you understand functions, all right? And hopefully this was an interesting little set of pop quizzes. If you're in my class taking one of my chapter tests, I'm just not going to give you nice, easy questions. Now, you might end up looking like this. You might be like, wow, why do you have to make things so hard, Mr. YouTube Math Man? Just give me the nice, easy stuff. Well, listen, the nice, easy stuff is not necessarily, what you need to be challenged with to see if you have a solid understanding of the material. Okay, if you have a solid understanding of the material, you can kind of connect the dots, right? You learn something about what a function is, inverse functions, different type of functions, domain, range, all this, independent concepts. What you have to do in your brain is you got to connect the dots so that all this stuff kind of assimilates into your brain housing group, okay, right up here. And that's what we call, learning at a higher order, right? This is where you really truly understand this stuff so you can apply it. Okay, so if you truly want to learn mathematics, you got to kind of, apply yourself, right? Dedicate yourself. Take notes, study, ask questions, get your questions answered, and challenge yourself. And test quizzes, all this stuff. Always, the whole purpose of this stuff is to give you feedback, right? There's no such thing as failure. Just even if you didn't do well here, it doesn't mean you can't learn this, right? Just use it as feedback to improve. Okay, so hopefully this little video helped you out. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.